So, mean deviation in 5 minutes or less. Roughly around page 73 of your book, as textbooks change over time, might be on a slightly different page. Mean deviation is typically used on samples, and otherwise, if we're working on larger samples, mini samples representing a population, we would tend to use standard deviation. But this is a great way to introduce the concept of deviation. So what is deviation? It is a measure, in other words, a specific value of dispersion. What is dispersion? Dispersion is simply how much things are dispersed, scattered, pushed away from what? The mean. How far are things, observations, scattered away from the mean? So, mean deviation is a single value. We want to know exactly how much deviation is there. What is the value, the single value of mean deviation? It's an absolute value. What does that mean? It's positive. It's going to be a positive number. And it incorporates every single value of your data set. So here's the formula. What's the first thing that you need to do? Did you say calculate the sample mean? I hope so, because you cannot get started on this formula without it. We know from the order of operations that we start within parentheses first. Well, we don't have parentheses, but we do have these little straight bars, which mean take the absolute value. So we start inside of there, and we have x. We'll talk about that in a second, and we have x bar. So go and calculate x bar. What is x bar? The average, right? Go get the average. Now, what are we going to do next? You are going to subtract the average from each and every single value in your data set. Did she say sum up the data set and subtract the mean? No, what? No, she didn't say that. Each and every value, subtract the average. But what if you have 100 observations in your data set? Then you will be subtracting the mean from each and every of those 100 values. You'll do 100 subtractions. If you have 1,000 points in your data set, you'll do 1,000 subtractions. What do you do next? Well, subtract, subtract, subtract. Then you're going to have some negative numbers and you're going to have some positive numbers. But these bars say take the absolute value, which mean that you must convert everything into a positive. So do that. Now, what is this here? This is the capital letter S in Greek, and it means to sum. So only after you have taken each of those 1 million observations in your data set, and 1 million times you have subtracted and subtracted and subtracted your sample mean. And for each of those million values, some of them are already positive, but you'll make them positive if they're not. Now you're going to sum up those differences. After you have the sum, you will divide by the number of observations. Did you have 10 observations? Did you have 1 million observations? You're going to divide by it here, and then you'll have the answer. Now, if we were going to spell out this formula step by step by step, this is what it would look like. Calculate the arithmetic mean. You'll need it. You always need it. Go calculate it, right? Organize your data into columns where the very first column is all of the values in your sample, all those observations. List them out. Now, take each and every value in your data set and subtract the arithmetic mean. Now, go back to that difference that you just calculated. Make all those differences positive values. Finally, sum. For me, it's helpful, depending on what tool you use, to sum underneath. And finally, divide by the number of observations. Let's see if we can do this. I'm going to use Excel. You can certainly use your calculator, but if you have a lot of values in your data set, this is the way to do it. Here are the values in my data set. I've listed them all out. I just typed them in. Somebody's got to do it, right? Now, I need to calculate the mean. I think I'll do that here in this yellow box. Excel has this great little tool. It says calculate the average. And I'm going to start here, and I'm going to go all the way down to my very last data set. I have 70 And in a flash, I have calculated the average. Do you want to see that formula? It's just the simple average function in Excel. Now, what is my next step? Make a column where column 1 is all your values. Of course, I did that because that helped me to calculate my average. But in column 2, subtract the mean from each of these values in column 1. So I've clicked in this cell. I'm going to type the equal sign, which says to Excel, hey, go into your calculator mode and pay attention to what I'm doing. Just by typing that equal sign, it did that. I'm going to click the first value. I'm supposed to subtract. What am I supposed to subtract? I'm going to subtract this value. Now, some of you may know this little key here, which is that as I copy this formula to each of the other cells, I do want it to get the next value, which is in A4, the next value, which is in A5 and A6. So this number is going to be changing. But I don't want G2 to change, because G2, not G3, not G4, not G5, but G2 is always going to contain my X bar, right, my sample mean. So if you simply will type a $sign before the column and the row, in other words, you just disrupt that cell name with $signs. Some people do this very quickly by simply pressing the F4 key on your keyboard. So does 425 minus 490, does that look right? It does to me. So I'm going to copy that into all the cells. Now you're busy punching this into your calculator, and that's great. You might want to pause the video. Okay, now you'll notice that some of these values are negative, and then round about where it gets close to 490, which is our sample mean, then it starts to change, right? And now we're into the positive numbers here, so you can see where the data would balance out the fulcrum that we talked about in class of our data. But what's the next step? The next step is to take the absolute value that's in our formula. So we're going to convert all of these to positive. An easy function in Excel, again, my equal sign ABS stands for absolute value. If I'm going to type the function, I immediately open my parenthesis, no space, just open the parenthesis, click my cell value, close. What am I going to do? Okay, see that little notch? Can you see that? Let me make that really big so that you can see it. Here comes my puffy white plus sign. When I hit the edge, see that shape? That's for moving. I don't want to move. See this shape? Watch carefully. Right on that node there, that little lower right-hand corner, I get a thin black plus sign. Press and drag. That's how you copy the formulas. There are many ways. This is just my way. Okay, so there's all my values. Now that was 70 of them. If you're still doing this in your calculator, pause the video so you can catch up. Okay, so then what do? Step number 5, sum those values. So did we do that? I think I've already even had that pre-filled in. Excel has a wonderful summing function here. You just click that and it sums that up. Did I do all my steps? Divide the value from step 5 by the count of the items. Oh, there it is, right there in A74. Okay, so we take, let me just highlight those cells, this sum, 3,134.14, we divide it by 70, which is a count of our observations, and we find out that the mean deviation is about 45. In our case, we were looking at rent values, renting an apartment, and so it's about $45. Now, how did that compare to the range? Well, as you know, if we were calculating the range, we would only use the highest value. My data is sorted, and we would subtract the lowest value. Well, I think that the difference between any, the mean in any of these points is much better represented by $45 than it is by 190. And you can double check that. Just kind of glance at this particular column, column B. Only a few of those values are even up here in the hundreds. You know, so the range of 190 obviously only represents the extreme lowest of low and highest of high values, whereas these values in the middle are much better represented by the mean deviation. Thank you very much.